do some basic distance formula problems, and I'm going to start with a very simple one, and then I have a couple more that I chose because I hope they'll address some questions that sometimes crop up with these sorts of problems. So I'm going to start by writing the formula out here again. 1 squared plus y2 minus y1 squared, and that's all over. It's all under this radical. So I thought I'd start with a very simple one. I chose this for our first point, minus 1 minus 5, and for the second point I chose 2 minus 3. So this is just a simple distance formula. Just fill in the formula and solve. So the distance is equal to our x2, which is 2, minus our x1, which is 1, squared, plus our y2, which is minus 3, minus our y1, which is minus 5, squared. Simplify. And remember, a minus is a positive. So this is 3 squared plus minus 3 minus minus 5, which is plus 5, which is 2 squared. This equals the square root of 9 plus 4, and that is the square root of 13. So that was a relatively basic one. So let's move on to another one that often brings up questions. They usually give you basic ones like these, and then they'll throw one of these ones that I'm about to show you at you. And it's not any more difficult than the other one. It just sometimes it causes some general confusion because, well, we'll talk about it. So here are the points. So for point number 1, we have minus 4, 1. And for point 2, we have minus 7, minus 9. And the reason that this causes some confusion sometime is because, I don't know if you've noticed that these points are not in order. Minus 7 comes before minus 4, so if we had our graph, here would be minus 4 and here would be minus 7. So if we are organizing our points the way that they're normally organized, this one with the minus 7, this would be x1, and then this one would be x2. But this first point over here is the minus 4 point. So a fair question to ask is, does it matter what order the points are in when you do the distance formula? And the answer is no. And I'm going to demonstrate that by doing the distance formula twice. So let's get a different color first. So let's do it the way they have it written here first. This one and this one. So the distance is equal to the square root minus 7 minus 4 squared plus minus 9 minus 1 squared. Simplify. So minus 7 minus 4, again that becomes a plus. So we have minus 3 squared and minus 10. So right away, if you notice, we have negative numbers here, and if you've been working some basic problems, most of them have always been positive. The only time you'll ever see a negative number under these radicals doing the distance formula is when you have these points that are not in numerical order according to the x-axis. So sometimes that will throw people off because they'll think they've done something wrong, but as we'll see, when you square a negative number, you multiply two negatives, which cancels the negative. So it gives us positives again. So minus 3 squared is 9, because negative 3 times negative 3 is positive 9, plus 10. So this, again, you have negative 10 times negative 10, which is just, I'm sorry, 100. That's what I meant to write. I'm sorry about that. And that's equal to the square root of 109. But let's switch these points. We'll switch this one and this one, and we'll see what happens. See if it gives us the same answer. But theoretically, if you just think about it, distances are always positive. It doesn't matter if I go, if I measure, say these are 2 points, if I measure this way or this way, it'll be the same distance. The direction will be different, but it's the same distance. So we'll do the distance formula again. But again, we're switching these points. So this is going to be the first point, and this will be the second point. So we have a square root. Again, we switched them, so this is going to be, well, let me rewrite them so there's absolutely no confusion. So point 1 will be minus 7, minus 9, and point 2, minus 4, 1. So we have minus 4 minus 7 squared plus 1 minus 9 squared. So when we simplify, we're going to get minus 4 minus 7. So this is positive 3. And 1 minus a minus 9, that's just positive 10. So if you notice, we have the exact same numbers, except here they're negative, and here they're positive. And they're negative here because we're measuring it this way. We're going from right to left rather than from our usual left to right. So that's what causes the negative. But as you're going to see, it's going to give us the same answer. It's going to give us, again, it's going to give us 3 squared, which is 9, and it's going to give us 10 squared, which is 100, which is the square root of 109. So you can see we got 109 here and 109 here. So we got the same answer. It doesn't matter what order the points are in. It's going to give you the same distance every single time. And I have one more example I want to do, and I want to do this example for 2 reasons. First of all, because we're going to be dealing with variables, and second, because one component of underneath our radical is going to cancel out, and I'm going to explain to you why that happens and what does it mean exactly. So I picked for this one, for the first point, I picked v minus w and t, and for the second point I picked, what was it, v plus w? Yeah, it was v plus w. v plus w t. So when we first found out when we first derived the distance formula, we were dealing with variables, but sometimes they can be a little bit confusing, and that was not the only reason why I picked this. So let's go ahead and do the distance formula. So the distance is equal to, I need an extra large one, v plus w, which is our x2, minus v minus w. And this whole thing is squared, plus t minus t squared. And we're going to simplify this. We get, well, let me distribute this first. So just to make sure, everyone sees it. So we distribute this minus sign, v minus w, and then minus a minus w. So this is plus w, and this whole thing is squared. And then this, and then this. See, this is the term I was talking about that's going to cancel out. T minus t is 0, and 0 squared is 0. So this whole term is gone. And we're left with this term, and when we simplify this, this is equal to 2w squared. And we can distribute this squared and we'd get 4w squared, but we have a radical, we have a square, they cancel out, and we're just left with the absolute value of 2w. And the reason this is an absolute value is because we don't know what w is. It's a distance, so it needs to be positive, but w can be, it could be 10, it could be minus 10. If it's minus 10, if we didn't have the absolute value, we would have minus 20, which is an impossible distance. So that's why we have the absolute value sign. But let me talk about what happened here. Sometimes people will be, this is another thing that is, sometimes people will make more of it than what it really is. So let me draw a graph and show you exactly what's happening. As you can see, they're both the same y value. So when you have two of something on the same y, that means if you have two of the same x or y, that means they're going to be either horizontal or vertical from each other. But it's very easy to see graphically, so let's go and do that. Get our line tool. I'm not really going to make much of a negative axis, it's just unnecessary. Alright, that's close enough. So, let's suppose, alright, so we had v minus w t, and this is point 1, point 2 is v plus wt. Alright, so say we wanted to graph this. So this is our x this is going to be our x coordinates. They're all variables, so we kind of just guess where they are. But let's go ahead and do t first because it's 1. So it has t height. So let's just say this is t height. Now, both of these are going to be on the t. Both of these are going to be on the t line somewhere. This is height of t, and this is v minus w on it, and this is v plus w on it. So let's just say this is v minus w, and then this is v plus w. They're horizontal from each other. So that means there is no, when we're doing our difference formula, basically what it means, it's unnecessary to make a triangle. Because they're horizontal from each other. We know what the x values are, so we can just subtract. It's just really, we could even count. Let's do an example with numbers. It'll be much easier to see. So another graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's make up some points. Let's make up, say 2, 4, and 4, and 4. So this will be our first point. This will be our second point. Let's graph them. 2, 4, right there. 4, 4, right there. So we could use the distance formula to solve the distance between these 2 points. But as you can see, it's completely unnecessary. We could just subtract. So this is 2, and this is 4. And then the height is 4. So all we need to find out is how far that was. 4 minus 2. Well, that's just 2. So the distance is 2. So the only time we really need to use the distance formula is when there is a diagonal. Because anytime we have a vertical or horizontal line, we can just subtract to figure that out because we're given the horizontal and we're given the vertical values. And like I said, it's just completely unnecessary to use the distance formula. So you can just count 1, 2. So, I mean, we can go ahead and do the distance formula just to prove the fact. So we have 4 minus 2 squared plus 4 minus 4 squared. So the distance is equal to square root of 2 squared, and then this other one drops off. We have the radical and the square cancel each other out, so the distance is equal to 2.